OSI. It stands for Open Systems Interconnection. This is actually a very cool concept, and I'm going to explain it through an example. So we are going to look inside the postal system. Yes, I know you use emails, you don't use letters, but still the postal system is very simple and there's a lot of similarity to computer networks, so I think you will relate to it better. Okay, so here is the story. There is a hostel. So this is the hostel. Excuse my drawing, I'm not particularly good at it. So this is the hostel. And there are students in the hostel, people like you. So these are the students. And these students generate letters. So these are the letters. So while we are at it, let me mention that these are the components of the system. And these components have some functionality. For example, the functionality of the hostel is to support the students. So this is what it does, and the functionality of the students is to generate letters. Let's also assume that this hostel has a hostel boy. Just to distinguish him from the students, let's give him a single strand of hair. I think that's kind of funny. So this is the hostel boy. What is his role? He basically collects letters from the students and gives them to the postman, and he picks up letters from the postman and he distributes it back to the students. So I'm calling this multiplexing and demultiplexing of letters. So that's his role. So since I mentioned postmen, so there are a bunch of postal people. I'm just calling everyone postmen again to distinguish them. Let's give them some hats. So these are the postmen. So the postmen do a lot of functionality. So one definitely is, once the letter reaches them, they need to figure out how to send this letter. So basically they determine the path of the letter. For example, if you send a letter to someone in California, then they decide it will have to go through the aeroplane. If you send to someone in Chennai, they'll decide it has to go through the train. So they kind of decide that. And then they also tend to bundle up the letters depending upon the destination. So if they will aggregate all letters that are going to the airport, all letters that are going to the train station, and so on. Naturally, there is some other infrastructure in the form of roads. So let me draw a truck that kind of takes the letters. I mean, this could be an aeroplane as well, or even a bullock cart. So basically, this functionality of this infrastructure is in transporting the letters. So the actual path of the letter, it goes from the student to the office boy to the postman, maybe over an aeroplane, and then maybe a truck, all the way to another postman who is going to deliver it to the person at the other end. So as you can see, the system has a lot of components which execute different functionality to finally get the letter from one person to the other person. Even though the postal system is much simpler than the computer network system, there are many challenges. You should be able to send letters anywhere, international, national, or even villages. Many people are going to use it, and these people will have lot of different requirements. Some may want reliable transfer of letters, some may want the letters to be delivered very fast, some may want the cheapest way to send letters. And also the system employs different technology to transfer the letters, aeroplanes, trucks, trains, including bullock carts. So it's kind of, there are all these things you need to achieve as part of the system design. Now that you have seen how the postal system works, now let's translate the system to computer networks. So here are a bunch of questions for you. Okay, so here is the summary of the translation. So hostels translate into computers. The students translate into processes that generate messages. So that means letters translate to messages. So the functionality of the computers is to support the processes, and the functionality of the processes is to generate messages. The hostel boy is basically implemented as software whose job is to multiplex and demultiplex the messages, and the postmen translate to routers whose job is to determine path taken by the messages. This bundling of letters is another functionality which again is kind of implemented in software. So this translates to hop transfer. Basically, there you decided that you have to go from the post office to the airport or to the train station. So you're deciding where to send the bundle to. So that's hop transfer. And this infrastructure kind of translates to hardware and cables. So this actual physical transfer of the messages. So this is the translation from the postal system to the computer network system. So the computer system is a lot more complex than the postal system. You have users that run into billions. These users can be anywhere in the world. Not only do they want reliable, express, cheap transfer of messages, they want interactive, that basically means supporting video and audio. They also want multicast support, which means they send one message, they want this message to reach multiple users. And internet as such also has to support heterogeneous technology. Remember, we talked about personal area networks, wide area networks, local area networks. So there are many ways to get connectivity. So the computer network systems has to support all these technologies as well. As you can see, it's a rather complex task to achieve. So how does one go about it? Right, object-oriented programming to the rescue. So whenever we have a complex task, it makes sense to segregate functionality into objects. In this particular case, we call them layers. And we hide the details of how this object is implemented from the users of that object by defining an interface. So users interface with the object through a interface. Now we started out with OSI, and you must be wondering, what is all this to do with the OSI protocol stack? Patience, we are almost there. At least you can see the words protocol stack. OSI is coming up shortly. So remember the functionality we covered as part of the example. Basically, each such functionality is implemented as a layer. So in the internet protocol stack, we have 5 layers. Okay, these are the 5 layers. The application layer supports the application processes which generate messages. And there are many protocols. So these are all the protocols that can be implemented as part of the application layer. So email will take care of your email needs, web will take care of your browsing needs, file transfer will take care of your file transfer needs. Similarly, the transport layer, remember the multiplexing, demultiplexing we talked about, that is implemented as part of the transport layer. Apart from this functionality, it can also provide reliability. So basically this layer supervises the process-to-process communication. Even here we have multiple protocols. Why multiple protocols? Basically it gives you a choice. For example, UDP does not support reliability. So if you don't want reliability for your applications, you can just use UDP. TCP on the other hand supports reliability. Similarly, determining the path is the function of the network layer, and the protocol that is implemented here is IP, and enabling hop-to-hop message transfer is functionality is implemented at the link layer, and you have a bunch of protocols here, Ethernet, Wi-Fi, so on and so forth. and the actual transmission of bits on the media is handled by the physical layer. And even here there are a bunch of protocols. 10BASE-T is part of the Ethernet standard. OFDM is a wireless physical layer protocol. And there are many advantages to such a layering. So you see, we took a complex task, divided into layers. So now it appears less complex because now we can identify the different pieces, the relationship between them. So it kind of gives us an overall grasp of the problem. And not only that, it also permits software reuse. What do I mean by this? So for example, if you want reliability, the web needs reliability, email needs reliability, both of them can now use the same transport layer protocol. This is something like calling the same function from multiple other functions. So now you have software reuse. And not only this, this abstraction of implementation allows extensibility and new technologies to be easily added. For example, if you want to change some routing functionality, you don't have to touch the link layer, physical layer, or the transport layer. You just need to touch the routing layer. Similarly, you want to add a new physical layer because a new technology has come about. You just need to change the physical layer. That's about it. So there are a lot of advantages of layering, and this is one of the reasons why this model is what is used extensively in computer networks. So here is OSI at last. So this is basically a standard that specifies the different layers. So these are the layers, the functionality that is needed in this layer, and the interface between the layers. Okay, so that is what the standard specifies. The original OSI protocol stack had two other layers which I didn't cover earlier. One is the presentation layer. So this looks into delivery and formatting of information. For example, it lets you convert text from one format like RTF to ASCII. The session layer manages sessions. For example, it combines audio video streams, or it can provide authentication. But these days, these are not implemented as separate layers. These in fact are implemented as part of the application layer itself. An important point to note here is that each layer, you can view this as functions, can potentially call any other layer. So for example, this can call this can call this can call this, and so on and so forth. But the beauty of the segregation in the internet protocol stack is that each layer, for example, the network layer, uses the services of only the lower layer. In other words, it uses the services of the link layer only to achieve its own functionality. So this kind of segregation is not easy, but they achieve it, and this makes implementation very easy. So we'll cover some of this interlayer communications in the next video. So here is a look at the different protocols as part of the different layers. So application layer has a lot of protocols. You may be familiar with file transfer protocol, the telnet protocol, this is the web browsing protocol, this is the email protocol. We'll cover the rest of this as part of the course. At the transport layer, we have TCP protocol, UDP protocol. These links show that the application layer protocols uses either TCP or UDP. Some, like DNS, uses both TCP and UDP protocols. At the network layer, you have the IP protocol, which is the most important. This is a routing protocol that uses IP. At the link layer also, we have many protocols, Ethernet, token ring, Wi-Fi, so on and so forth. So as you can see, there are plenty of protocols as part of the internet protocol stack. So what have we learned from this video? So providing internet service is very similar to postal service. After all, both enable communication. And we have identified that there are many functionalities that need to be implemented, starting from reliability, routing, so on and so forth. Overall, the task is complex. Now, when you have a complex task, the best way to proceed is to modularize, hence the layering concept. And we have seen that they have many advantages to it: software reuse, can support new technologies, so on and so forth. So this layering also provides a very good framework to learn the subject systematically. You can either go top down, where you start with the application layer and go all the down till the physical layer, or you can go bottom up, where you start with the file layer and then go all the way till the application layer. So I personally tend to go top down if I want to keep the material light, mainly for non-CSC students, where the focus is more on the application layer. But for in-depth study, I prefer to go bottom up. That's because it provides a very nice building block approach. That is, we could start with just a link connecting two computers and then build by adding more computers to it. That becomes the link layer, and then interconnect these networks that forms the network layer, and then throw some applications and other aspects on top of it. So the next topic is how do the layers communicate with each other to achieve the required functionality.